Hello and welcome. This is 1876 session for VMware Code Apply End-to-End Networking Security in Multi-Cloud for VMware Tanzu users. My name is Tuan Nguyen, Senior Technologist from Networking and Security Business Group, and with Stefan Lis and Santosh Patel. Let's get started. The context of the new world now increasing tremendous attacks. With the pandemic happen, user can be remotely accessed to your environment. Could be on-prem, could be in the cloud, could be coming from their home or their Starbucks, from their any locations. It causes a lot of vulnerabilities, a lot of exploits for attackers. Can do multiple techniques attacking to your environment. And also on the development side, we have the DevSecOps cycle, which is much faster in development in deploy CI/CD. Now the application now is from the developers go into the operation team to the infra team, fully automate the end-to-end cycle. It helping very fast to deploy and develop the app, but it causes a lot of challenge for the security folks. How easily we can track, monitor, predict, and protect your environment. Let's look at the survey we have for this year in the multi-cloud customer journeys. 74% of customers now they have multi-cloud study. In the previous session we see it, and they do a lot of smart migrations to multi-cloud management across cloud consistently. And the last one is the cloud natives. Those are the key reason why customer moving to the cloud. And the key challenge, we look at the top concerns about across all of the customer we survey for. Security always the top 1 or 2 or 3 concerns, either the risk on the cloud migrations, the risk to lose the data, the security, privacy concerns, or for modern app, a skill set how you manage your modern apps. Then we have the solution in here. There's a whole max pyramid. We call it Modern App Connectivity Services from VMware Container Pyramid that help you to protect end-to-end. With the NSX data center is a foundation. If you do have one tied with your vSphere, and then all the way to layer 4, layer 7, we have CNI plugin with Antrea. We have ALB, which RV load balancer can do layer 4, layer 7. On the way to the top of the pyramid, we have Tanzu Service Mesh and Carbon Black Container Security. Then today, we're going to start to see how those things can play together to form the max bundle to help customer to solve the challenge for the security and the multi-cloud environment. Starting with Tanzu Service Mesh is give you the full visibility end-to-end. It's very easy to set it up, to install, and to manage. And we go all the way to the Carbon Black Container Security and take you all the way to NSX AOB for the load balancings to protect your north-south traffic like WAP, Web Application Firewall. On the way to Antrea is a layer 4 and layer 3 CNI plugin, and tied with NSX is scaled tremendously nicely in terms of the whole pyramid of protections and prevention. Let's look at the 2 use case we want to talk a lot today is the multi-cloud operations, how you manage your applications across the cloud, and for the zero trust security compliance, how you discover and secure and connect them together, either with Tanzu Service Mesh or with Carbon Black Container. You see in the picture here, see the Carbon Black can be installed at each cluster, and CNI plugin from Antrea to protect your endpoints and workload. And then on the way to the top, we have GNS. We did a concept from Tanzu Service Mesh. We talk a little bit later along the line with the talk and the live demo. And good thing, you can also do whatever I do in here. Follow me in the test ride environment right after the session. So look at the challenge. So now I just mentioned that Kubernetes is the core of the modern apps. You can run on-prem and public cloud, and along with VMs, virtual machine, all of the kind of things. And you need to trust. You can create on the API along the way. Almost every modern app services have an exposed an API. How you manage it easily, how you connect them to easily to see the full visibilities, and from there to make decision how you allow or block by policies when you see it, how it works in the Tanzu Service Mesh. And not only that, you need to do zero trust. You don't want every day to do XYZ thing. You have to be automated. That's everything be fully detected and prevented. So there are 5 different steps we need, right? How you do protecting north-south with the WAP, the bot detections from east-west traffic, end-to-end encryption. That's the first thing you do. And expose an API allow you to see all of the malicious things happening within the APIs. And we can call it API segmentation, where you see in the nice demo right after that, to protect the customer from the user to the application to consume and to the data they've been putting into the system. Then the answer is very simple. You see the whole story here. We take you to the whole journey, how you manage the complexity in the multi-clouds. Along with that, we have the modern app can be deployed anywhere and expose all the APIs, and naturally API become a new endpoints, and that helping to operate it with the guide rail with the end-to-end protection. And we can do either north-south with the load balancer from RV, NSX, AOB, or with API discovery from Tanzu Service Mesh, or with the endpoint workload protection with Carbon Black containers. And from there, you can form the full visibilities and apply all the policies along the line, automated and kept end-to-end protections for your modern app connectivities. Let's look how in the action, right? Before with that, we have some survey also from Akamai using 83 4-hour 5 type of web traffic today now is API traffic. You see, on kind of MySQL, MongoDB, Kafka, Redis, you name it, all of that is exposing API is exponentially more and more coming since the last few years. How are we going to deal with that? So the modern app is a mesh of services. That's one of the view we have in our Tanzu Service Mesh. Allow you to see end-to-end visibility. So in every services you see that if the attacker come from XYZ service, try to attack your, let's say the e-commerce app, try to attack your system, we're going to see it from the beginning, where it's landing, where it's going, how it's going to that, where they get to that, and how we're going to protect it based on what we see. And we can either alert or protect, create a rules or block certain traffics that not supposed to be with either whitelist or blacklist. Very quite flexible. Thing we do at the service mesh level, we create an abstraction at the higher layer, which is abstract from application layer to infrastructure, no touch at all. Whatever you have in your infrastructure, DNS, DHCP, where you manage either EKS, AKS, or you run a public cloud or private cloud, Tanzu, it doesn't matter. We abstract at the high layers very nicely. We have the sidecar concept inside the service mesh, allow you to abstract on together. The nice thing, because of that, we see the full end-to-end visibility. You see all the API together. We can easily define the SLO and security compliance. When you see the other session we talked earlier today, in this session more focused on how you protect your endpoints with the API. And we see the 3 keys major thing in API. Why we need to focus on API? Why now? Because of a lot of traffic today is API exposing. So API it need to build and run and manage the whole life cycle and expose the vulnerabilities. Is easy for attacker and then come and go and attack your system by attacking your API instead of attacking your other devices. That's easy now. So this is the whole life cycle of API end to end, from the depth sex of how you run the API, how you manage the policies, the API, how you measure that, how you run and testing API as well. That's the whole life cycle of API. And from there, you can take you to the next things. This is real life. You create the GNS across your cluster running either on-prem or public cloud. And from there, you see the traffic flowing. Any malicious thing happen because you have API protected and you turn on the encryption. So you protect your API as the first layers. And second layer, we're going to talk right after that, how you segment that, because you see the thing. So the more you see, the more you can protect, right? See more and stop more. Right? This is the whole initiative of Contexa. Tanzu Service Mesh Modern App is part of the context as well. So this is a whole feature set. We have connectivity, security, observability across user services and API. On the left side, you see the first session we talk about how you protect, how you create your app and resiliencies, scales across multiple clouds, connect them together in a high performance. On the right side is on the API security, any compromise PAIs, PCIs, compliance, API security, visibilities, thing we're gonna see in the demo right after that. Let's have two demos, first for Tanzu Service Mesh, and the second one for Kubernetes container. Along the line, we put AV WAF to protect your north-south. Tanzu Service Mesh is protection for east-west, so end-to-end for your solutions.
Thank you, Tuan. Let's look at the demo now. We have an Acme Fitness application deployed across 2 different clusters, and the clusters are onboarded to Tanzu Service Mesh. So VMware Tanzu Service Mesh provides policy control and visibility for all communication among applications, end user services, and APIs. Let's look at the global namespace configuration of the 2 clusters we have. The 2 clusters are, the cluster 1 has front-end services, and the cluster 2 here has a catalog and catalog DB. So this global namespace defines an application boundary and provides seamless connectivity, security, visibility between the clusters running on any cloud. We have API discovery and PI data discovery features enabled. And the shopping service has been configured on a public URL, shopping.vmware-demo.net. The GSLB resiliency configured as round robin. Let's switch back to the GNS view and see within the global namespace, the distributed services, which is part of the complete Acme applications, are discovered automatically. The shopping service and the catalog service, which are across 2 different clusters, are connected each other by the global namespace. Let's move to the security view. All the security policies applied here controls and regulates the connectivity between different services. As we can see, there is a policy applied between shopping and catalog, and a similar policy between order and the payment. Let's review the front-end and catalog service policy here. The application of control policies are straightforward. We can apply it on a respective namespace, source service, and the destination service, and the intent of the policy. I will switch to API view within the GNS. Similar to the services, all the communications between APIs and services, including API parameters, are automatically discovered. Let's look at the product service API data. So the schema has been identified automatically, and the data is represented on the JSON format. Similarly, all the interactions between the APIs are recorded on the API logs. Let's move to the PII information. Similar to the APIs, all the personally identifiable information exchanged between the application are monitored and tracked to verify and control the sensitive data. Just to demonstrate that, let us place an order in the fitness application and see how the data has been tracked within the service mesh here. So just proceeding to checkout and placing an order here on the application. Continuing with payment and place an order. So once the order is placed successfully, let's switch back to the TSM console and see how the data has been changed. Here, we can see within the Tanzu Service Mesh, a complete user transaction has been recorded from the shopping service to payment service. All the API data and including services has been captured here. You can see the data flow has been highlighted and the type of data which has been captured. The credit card information has been captured here. Now let's move on to the attacks view and see what data is captured there. It is evident from this section that an intrusion has been attempted and it is identified by Tanzu Service Mesh. The sensitive data here has been tracked with SQL injection. And we can see an SQL injection between shopping to gateway and the protocol violation within the shopping to catalog. And all the data has been captured here. Similar attacks can be prevented and identified and can be prevented by configuring respective security policies within the Tanzu Service Mesh. Let's configure an API security policy here. We have a shopping security policy which is defined, and each and every policy has been allowed here. Let's change the attack defenses from allow to deny all types of attacks, and the response code will respectively give us 490. Let's save this policy. What happens when somebody tries to attempt an intrusion? It can be denied. The malicious request can be found and can be denied within the API, and the respective response code will be showed to the end user. So to conclude the demo here, API security can enable for modern applications which can be run on multi-cluster, multi-cloud environment. It will enable DevOps and security operators to deliver applications to production with agility and security.
Thanks, Juan, for your presentation of NSX and Tanzu Service Mesh. Now I will talk about Carbon Black container security for compliance and vulnerability management. If you remember this pyramid, on this layer we have Tanzu Service Mesh and Carbon Black container security here. Carbon Black can complement Tanzu Service Mesh. There is no overlap at all between both products. And now I will explain the feature and how Carbon Black can protect your container. When we are talking about cloud native applications and how to attack or secure them, we are actually talking about several layers. Each has its vulnerabilities and attack patterns. The outer layers are more complex, but more generic, inviting use of common attack tools and security practices. The inner layers are more specific, even though the prevalence of open source in application development introduces some common weaknesses into the code layer. The topic of how to secure cloud infrastructure, whether it's a public or private, deserves its own talk, and probably more than one. In this talk, I will focus on the three inner layers, which are all specific to the use of containers-based runtime. A Kubernetes cluster is composed of a common control plane, which exposes an API that allows defining a desired state as a collection of resources and tracking the actual state of the resources. When it comes to running applications, which is the purpose of Kubernetes, of course, based on the defined resources, Kubernetes schedules pods to run in worker node. Each pod runs one or more containers, using specified container images. Each container runs one or more processes. When we speak about Kubernetes security, we need to understand the boundaries. The biggest infrastructure is a Kubernetes cluster. If you don't have a Tanzu Service Mesh, you have only one Kubernetes cluster. In one cluster, you have several nodes. And in a Kubernetes cluster, you can have a namespace that can be on different or several nodes. And in this namespace, you will have some pods containing some containers. It's important to understand all the name of this architecture. When we talk about security, we talk about attack. What are the attack vectors? First attack vector is service token. Attackers use credentials mounted in a compromised container to perform reconnaissance, move laterally, or run malicious workloads in the cluster. Another attack vector is a compromised container. Other than service token attack, leverage default network exposure of all the containers in the cluster as well as the control plane to all running containers. Network endpoints exploit application vulnerabilities, misconfiguration to compromise a container, exploit weak authentication, vulnerabilities or misconfiguration to attack the Kubernetes API server or kubelets. Denial of service, leverage weak resource isolation to crash processes in neighboring containers. Airbag issues, by obtaining unprivileged user credentials, attackers can escalate their privilege in the cluster by exploiting misconfigured airbag policies. Thanks to OWASP, we can categorize threats with this model. So we have threats like compromising secrets, like network threats, poisoned images, so container images, container outbreak because processes are running as root, usage of UID, etc. Kernel exploits, not very often, but when it happens, it's very widespread. And finally, the denial of service. It can be the network, file system, RAM, or CPU exhaustion. What are the possible mitigations? To harden the cluster, we can enforce strong authentication, limit network access, continuously install updates and patches, continuously review airbag policy to ensure least privilege, very important, always use least privilege. Harden workloads, it means apply pod security and other admission controller. I will explain what we can do with Carbon Black in the next slides. Scan images for vulnerabilities. So while building images, while storing in a container registry like Carbo and at runtime too. Everything we can do with Carbon Black container. Then harden runtime with network policy, seccomp profiles, and by keeping worker nodes up to date. And then apply runtime protection and response by monitoring workload behavior to detect known attack patterns and anomalous behavior. What about admission controller and workload hardening? Admission controllers can apply policy to Kubernetes resource definitions. It can deny the deployment of resources, or it can mutate resources before deployment to conform with policy. We have both in Carbon Black container. We can block or we can modify or mutate. I will show you in the next slide how it is. So each time someone, it can be a dev, it can be a sec, a ops, it can be a hacker too. Each time sometimes try to execute a kubectl command or try to run APIs or dashboard to the Kubernetes cluster. It will start with API HTTP handler, of course, so everything will come in this box first. There will be authentication, authorization, and then we will have some mutating, we will have some validation, admission, etc. And then it will be persisted to etcd. It means each time you create a new deployment, it starts from here, it goes up to the etcd. When you are authorized, then Carbon Black webhooks will connect to the mutating admission part here and will check, okay, do we need to mutate this deployment? Do we need to add some quotas? Do we need to remove privilege or something like this? Then it will be validated by Kubernetes. And then once again, Carbon Black will validate the final deployment file or final resources. And if it is validated, not blocked by Carbon Black, it will be persisted to etcd. Difference between Kubernetes security standard and Carbon Black guardrail. With Kubernetes security standard, each cluster is managed separately. There is no policy management tools. Policy violations are reported in cluster logs only predefined rules. It's difficult to create custom rules, in fact. Rules do not apply to image vulnerabilities. It's only on more compliance stuff. With Carbon Black, policy can be applied to a group of clusters, can be even multi-cloud. There is a UI for policy management, a cloud UI. Policy violations are reported in a dashboard, or in a common dashboard for all your Kubernetes cluster. For APIs, there are some APIs, some notifications, etc. There is a rich language for creating custom rules, so you can block something that is not defined by default. And we have rules to cover image vulnerabilities. For example, block the deployment of container with critical vulnerabilities, or block deployment of container with vulnerability with fixes. Well, we can think about a lot of things because you can create custom rules, so it's really open. About the vulnerability management, there is a vulnerability scanning in command line. So you can integrate it in your CI/CD pipeline, in Jenkins, GitLab, everywhere, during the build. Also, we have on-cluster scanning. So when Kubernetes cluster is running a lot of container image, it will scan automatically everything that is running in your Kubernetes cluster. There is a policy with exception management. So you can block, but except for one particular container, for example. There is a continuous scanning for new vulnerability, sorry. So it means that each time a feed or vulnerability feed is updated, we update the list of the vulnerabilities that we see in all container images. And of course, reporting is done via UI, APIs, and notifications. Here it's an example of dashboard. So it is a dashboard where we can see the status of all container images, the number of images with fixes. So here we have 20 critical image that has images with critical vulnerability, with fixes. So it should be your main concern, and you should work on this first. Here we can see the new vulnerabilities over the last 24 hours or for last day. And here we can see for each day the number of new vulnerabilities. Now let's talk about eBPF. eBPF is Extended Berkeley Packet Filter. It is a technology inside Linux kernel. And it can be used by Carbon Black container to run custom code in the Linux kernel and to attach to specific kernel events. It is used for monitoring and enforcement. So it can log a lot of things, and also it can block. So in Carbon Black container, what we'll do, we will monitor network activity, we'll monitor process execution, file access, we will identify execution of malware, identify access to public servers with bad reputation. We have an internet cloud reputation database. We will identify suspicious anomalous behavior based on machine learning. And if we look at the architecture, perhaps it's a big picture, but I will explain it. On the left, we have a Kubernetes master node. On the right, we have two Kubernetes worker nodes. And on the master, we will install all Carbon Black. Carbon Black, yes, is a cloud native application, so it's all running in Kubernetes. You don't need to install an OVA or something else. It's all running in your Kubernetes cluster. And in each node, in master or in worker nodes, we'll have a pod called node agent. It is a daemon set, so automatically it is installed in all your nodes, and this daemon set is in charge of speaking with eBPF runtime here in Linux OS. And with this, we are able to detect all network connection, file modification, etc. With Carbon Black Cloud, we can manage vulnerabilities. Vulnerabilities for your virtual machine, for your endpoint, and for container image. So here we have the list of all vulnerability for your container image on all your Kubernetes cluster. And we can see that we can detect vulnerability for RPM, Alpine package, Debian package, Java, Python, there is also Node.js, NPM, etc. So it is an overview. And for example, if you are looking for SQL injection, you can just search for SQL here, and we will see that one vulnerability has been found that is critical. There is a fix that is available. There are 2 images, 2 workloads. The risk is 7.5 and the fix number. So if I click on it, I will see that we have Acme Shop that has 10 critical vulnerabilities with 7 fixes available, and also Acme Shop Card. So it was Acme Shop Order and Acme Shop Card, same thing with some vulnerabilities. Then you want to know where they are running. So they are running here in this cluster, in this namespace. They are protected with this policy. There is no exception on this, and we have detail on this CVE. So the CVE description from the National Vulnerability Database, and also some details if it is difficult to reproduce the CVSS score, etc. For vulnerability management, especially for containers, we have a dashboard with all images with fixes here, with all new vulnerabilities from the last 24 hours, and here an historical graphic. It's all clickable, so I can select here critical, and I will have all the list of my container image that has critical vulnerabilities, and same thing, I can have all the detail. I can also check all image repositories that I am using. Currently, it's a good practice to block some dangerous or some very popular container registry like Docker Hub, who contains a lot of malware or a lot of containers with vulnerabilities. And here we have the scan log, sorry. And we can see that we have different scans. We can scan vulnerability using a CLI. So it is a CLI for using on your laptop or to integrate in your CI/CD pipeline in Jenkins, in GitLab, etc. We also have a feed update. In fact, each time we scan a container image inside Carbon Black in SAS, in the Carbon Black SAS, we record all the packages, all version number of all packages and libraries you are using, and we are able to update the vulnerability on a package when there is a feed update. So each time there is an update, for example, there is a new vulnerability in Java, as soon as we update our feed, we update here in this view all vulnerabilities in your container. So you don't have to wait for a new scan. We'll record everything. And of course, we have a cluster scan. I mean, each time a container is running in your Kubernetes cluster, we will scan for this new container with all packages, etc. So it is done automatically, or it is done before the production in your CI/CD pipeline, or if you want to do it manually. Of course, the result of this scan can be used in Kubernetes policy. So for Kubernetes policy, we have 2 kinds of policies. We have hardening policies and we have runtime policies. Runtime policy is to detect malicious behaviors on network based on machine learning and behavioral analysis. And hardening policy, I will create one demo. I will use a scope test. Yes, there is not. Yes, here there is a lot of image. And in hardening policy, we can, for example, block execution to the container. So you cannot do kubectl exec and then run code in your container, because it is very easy if you have access to the node, then to take access to the container and execute code in the container. So this can be blocked here very easily. You can block port forward. Concerning vulnerabilities, also in the Kubernetes policy, we can say we don't want to have critical vulnerability in our bleed, so we can block critical vulnerability deployment. We can block latest tag, images that are not scanned, image without hashtags, etc. And also we have something new, which is the enforcement. Enforcement means we can alert, block, or we can mutate the deployment. Mutate the deployment means if you try to deploy something without CPU limits, we can automatically add some quotas for CPU, for memory, or we can add some other parameters in your deployment file automatically. For example, block the privilege escalation, privilege container, etc.
Let's have the recap. So we just saw the whole demo here. So the two key things, the zero trust, security, and compliance with Tanzu Service Mesh, the simplified multi-cloud operations with Tanzu Service Mesh, and the common like container. Together, we play the end-to-end solutions. And let's look at the whole pyramid again together. Let's see what you see today. And let me go into the conclusion, right? So let's have a look. What you're gonna take away from that? So Tanzu Service Mesh is part of the context end-to-end protections from the user to the cloud native to the hybrid cloud, either virtual machine or containers. It's a threat intelligent cloud. It runs along with other products to form the end-to-end solutions with machine learning run behind, and we can see more and stop more. And look at those are material you can take away and check it out for those links and the other session we running through. Check out, go to the booths, and we see all the sessions we have at the booth and the expo. And check out the hands-on lab for networking and security. The Texon, more than 500 articles published almost every week, every month. And the portal VMware-testdrive.com allow you to go and hands-on whatever you saw in the demo. You can go and hands-on easily how quick, how fast we can do together. And then last but not least, on the latest and greatest demos for the security and networking track, go to the expo, see all the demos from the secure modern app to your multi-clouds, your ransomware scenario, how you prevent with NSX, with Tanzu Service Mesh, with Common Black, all the solution from VMware portfolio, and to the cloud with VMware on AWS and XCX to move your workload from on-prem to the cloud in a secure fashion. And all kind of solution you see at the booth. Please check it out. And also those are key sessions along the keynotes and other session as well. Thanks you. Please take a survey and get back to us for any questions. Thank you very much.